to Wildcat Academy. Due to the weather, we haven't been able to film in a while, but today we're going to sit in on Phil Swartzentruber's sophomore geometry class, and he's going to be discussing Pythagorean Theorem and how to apply it in your math class.
7 through 21 and get that finished up. Number 1 is on the board here. Which is our hypotenuse in number 1? It's the x. And remember the formula for the Pythagorean Theorem. Is what? What's the formula?
A squared plus B squared equals C squared.
A squared plus B squared equals C squared. And in our formula, which one is the hypotenuse? A, B, or C?
C.
C. Okay, so we're going to set this one up by saying 12 squared plus 35 squared equals x squared. Right? 12 squared is 144.
1225.
And what?
1225.
1225. And when you add those together, you get what?
1369.
1369 equals x squared. Okay, now when you get to this step, you square root both, take the square root of both sides.
37.
Square root of 1369 equals x squared. I'm sorry, equals x, because you took the square root of both sides. And what is the square root of 1369? 37. Now, there's a special name we give to numbers like 12, 35, and 37. Numbers that fit the Pythagorean Theorem. What do you call 3 numbers that fit the Pythagorean Theorem? 3 whole numbers. A what?
Pythagorean triple.
Pythagorean triple. Okay? That's an important name to remember, because you'll see that from time to time. They'll ask, are these 3 numbers a Pythagorean triple? I've seen questions like that on the ACT and on other tests like that. So just make sure you know that it has to be 3 whole numbers, and they have to fit the Pythagorean theorem. Okay, number 2. Which one is our hypotenuse?
X.
Actually, does somebody want to come up and work this one out for us on the board? Anybody?
Which one is it, 7?
I'll be glad to give you my marker.
It's 2.
Oh.
Okay.
We'll do it.
Who wants to?
I'll do it.
Okay.
Okay.
Way to get in there.
All of it.
Okay. Let's talk now about where the numbers came from that he's got here. Where did the 49 come from?
7 squared.
Okay, that would be 7 squared. Where did the 81 come from?
9 squared.
9 squared. And probably one thing he should have done, what should he do with the C?
Squared.
It should be squared, okay? He knew what he was doing, because he got 130, and so then you take the square root of the 130 to find C, and when you work that out or put that in your calculator, it's 11.401. Questions about number 2? Number 3 is a little different, right?
Yeah.
What's different about number 3?
5 is the hypotenuse length.
5 is the longest side. So 5 is your hypotenuse. So you're going to, which one is A?
3 or X.
3 or X. Doesn't matter whether you call 3A or XA.
No.
No, it doesn't matter. A and B, it doesn't matter which order you use those in. What does matter is that you've got the longest side as your hypotenuse. So, 3 squared plus x squared equals 5 squared, right? What's 3 squared?
9.
9. What's x squared? Okay. That's what we're trying to find, is x squared. What's 5 squared?
25.
25.
You subtract that.
Subtract what?
9.
Subtract the 9. We're trying to get the x squared by itself. So we subtract 9 and get x squared equals what?
16.
16. How do I find x?
Find the square root of 16.
The square root.
Hey, Schwartz,
Yes.
I got the right answer, but I didn't put x squared, I put base squared, does that matter?
Okay. No, that's fine. You were using the formula, the letters out of the formula, and that's fine as long as you know that the b you find in the formula is really the x they're looking for up here. And the square root of 16 is? 4. Question so far? I want us to look at number 4 yet. I'm pleased with, you all really seem to be catching on to this well. I'm pleased with that. And in number 4, we again know the hypotenuse and we're trying to find one of the legs. And 13 and 11. This is what we're trying to find. Okay.
13.
Is there somebody that wants to come and work this one out for us? Anybody?
I'll do it.
Okay. Okay. Thank you. So you subtract 121 off of both sides and you get 48. And then you take the square root of 48 to find your x. And that gives you 6.9. I want to show you, I will accept 6.9 or the square root of 48 as an answer. Those are correct answers. I did want to show you one thing that if you're doing this like on a multiple choice test like the ACT or something, and you get the square root of 48 as an answer, sometimes they want that in what they call simplest radical form. Now, simplest radical form, you're going to break down the square root of 48, and here's the way you would do it, and we'll work more on this later in this chapter, but you would write the square root of 48 as two numbers, the product of two numbers, one of which you can take the square root of. Now, think about the number 16. If I would write the square root of 48 as 16 times 3, right? Is 16 times 3 equal to 48? Somebody punch in your calculator and see if 16 times 3 equals 48.
Yeah,
So we're doing it right. Okay. So 16 times 3 equals 48. What's the square root of 16?
4.
4. So I could bring that out from under the square root, and the 3 stays under the square root. So I could write the square root of 48 as 4 times the square root of 3. And if you check that on your calculator, it also comes out to be 6.9. So this is just another way of writing it. This is called simplest radical, because radical is a square root. Simplest radical form is the 4 square root of 3. And you'll see that as 4 square root.